Okay, now let's continue with the session. Taking some break. The things what I have completed is actually it is a historical database application in UNIT1. In that, the topics to be I covered is historical perspectives, which is about 20 minutes class, and file system versus DBMS is another 20 minutes class, and the data model is another 20 minutes class. So 1 hour have taken this. The next topic, which I have already given the introduction in the last class. Now let's go to the, from here we can start the class. Now the topic is, subtopic of a database system application is levels of abstraction in DBMS. There are 3 levels in data abstraction. What is data abstraction? Data means, it is a fact, a collection of information. We are abstracting means we're taking the features of the real world entity or some entity so that we can freely access or easily access the data, manipulate the data or update the data respectively according to our needs. So this is called data abstraction. Abstracting means we are taking some of the features of the data where the table which is created can be used for further alterations or manipulations or updations. So this is called data abstractions. In this, the levels are 3 are there. Actually, there are so many levels, but theoretically, we'll be reading only 3 levels. The first level is nothing but the physical level. So the physical level, this is the lowest level of the data abstraction. So this is the diagram which is coming in the coming slide. So to explain this, I have gone little further. Now see, this is the lowest level. The next level is the logical level. The next is the view level. Okay, what is this? I will tell you exactly. Physical means where all the physical items will be here, and logical is where we have the software address part, pointers part, and this linkages part. And the view level is nothing but the users or a database administrator or the customers or the persons who's operating this database. Okay. So let's come into levels. The first part is nothing but the physical level, which is the lowest level of the data abstraction. It tells us how the data is actually stored in the memory. Memory, again, there are so many types of memories are there. RAM, ROM, physical memory, temporary memory, hard disk memories. So many types of memories are there. It can be, well, coming to this is the internal part of the computer, or the external part is nothing but the fog memory, the cloud memory, next the blockchain memory, and some of the blockchain platforms can like Ethereum, Soluma, or Palka. So many types are there. That are the types of blockchains I mean to tell. This is about the general knowledge. For the general knowledge sake, I'm telling all this, where the data storage can be done according to the need and the need to be accessed. Next, the access methods can be done both sequentially and randomly. Sequentially means it comes in the, for example, it can be the ascending sequential or descending sequential. For example, after 1, what is the next number? 2. After 2, 3. Like this is called a sequence. Okay. Random means suddenly I can go to the 50th file. Otherwise, I can go to the first file. Otherwise, I can go to the 99th file. So this is called random access in the file organization methods. Next, and file organization methods like trees, hashing, used for the same. See, B trees is a sort of sequential and also random. Hashing is nothing but completely random type. Usability, size of memory, and number of times the records are factors which we need to know by designing the database. So what is this actually? Usability means what we are going to use. What is the size of the memory? See, before buying the system, what is the RAM size? 512. Like this, we are going 1 gigabyte. What is 2 GB? So this is the memory size. According to our usage, the size of memory also increases or decreases. But once the size is fixed, we fixed to one size, we have to use that one in a particular manner, and the number of times the records of facts which need to know while designing the database. Uh, so this number of times the record can be accessed so that we can design the database according to our need. Suppose we need to store the details of an employee. For example, this is the something. So blocks the storage and the amount of memory used for the purpose to keep hidden from the user. Suppose we want the details. We want the details of his phone number only. When I need the particular employee 101 called Ramu or some ABC, 101 employee name is what? ABC, where I need his contact number. So when I need his contact number, I can only have the details of his contact number. The remaining part, like is how much the salary, when he is joined, what is his experience, some others, what is his PAN card, Aadhaar card. The other side of the table, that is employee table, will be blocked and will be stored in somewhere in the server or the main storage. So only the part which we have to do some alterations or updations or to be seen or to view, only that part is to be taken and the remaining part is been hidden according to our purpose of need. So this is about the physical level. The next level is nothing but the logical level. So this is the middle level. So this level comprises of the information that is actually stored in the database in the form of tables. So your information is stored in where? Stored in somewhere, that is some warehouse. But in the warehouse, where we store exactly we store it in the form of tables. Tables is nothing but the combination of rows and columns. So tuples and attributes. So this is what we are going to see in the second unit. It also stores the relationship among the data entities with relatively simple structures. At this level, the information available to the user at the view level is unknown. So at this level, information, whatever is available to the user for the view level is not unknown because it's a logical type. Where it, what table is retrieving, how it is retrieving, which is being related to. This is all not concerned with the view level at all. We just want the data. Whatever queries we have typed, we'll get that answer. What internally the system is doing, it is nothing but the relationship between the tables, how it is storing, how we can access, what the type of updation is doing. So what are security, what is the conditions for that? Any nested queries are there? Anything of constraints are there? All this is seen by the logical level. So this is not need to the view level at all. That's what I mean. We can store the various attributes of the employer, that is the characteristics of the employee. For example, attributes of the employee can be employee ID, employee name also there can be a subdivision called first employee name, second employee name, and the last name. Next, employee address. Next is age, date of joining, and how much salary is taking, what is the experience, what is his designation. All these are nothing but the attributes of the employee and the relationship between them. That is, example with the manager can also be stored. So we are storing all this employees under the manager table. So this is nothing but again relationship starts so that the manager have easy access to the employee or something like this. So this is what I'm telling the example for a storage of attributes and the relationship at this level. The toughest level is nothing but the view level. This is the highest level of abstraction. Only a part of actual database is viewed by the users. We can see what is the data, how is the data, what is the data, what are the commands we can give it, what are the queries we can do it. This level exists easy to access the database by the individual users. So by the individual users, we can access it. User view data in the form of rows and columns. How the data are viewed in the form of rows and columns. Tables and relations are used for stored data. Okay. Multiple views are also in the database may exist only to view. At the same time, we can even store it that is a different type of commands. For example, how we use cookies in our system. Cookies is whatever the most wanted part, but not stored in the system storage. So that is a type 9. That is nothing but cookies in the laptop. Okay, in your desktop also. The same way, views also is nothing but a virtual table. So we can only see it, and at the same time, we can store if it is needed. Same example like cookies. I'm giving a small example so that for the understanding purpose. Users can just view the data, interact with the database, store it, implement it, update it, and hide from them from any of the other intruders. So the basic diagram is this is the lowest level called the physical, logical, and the view. View, how many views can be? N number of views can be. This is the world is infinite number of informations. So viewers also are infinite. So they can view infinite number of viewers are there. So there, this is called a view level. Suppose, for example, Google. How many persons are using the Google? Many, n persons. Are we counting in a daily basis? No. So that is called the view level. We are just having a query on the Google. We just texting it. For example, I want to know what is the advanced databases available in the market. I'll be typing in a Google. We'll get the proper answer. So what happening is I am in the view level. I am just telling what are the advanced databases available in the market. So internally, what the system does, it interrogates with the Google storage logically and get it from the a physical level where the actual data information is stored. From there, again, links with the logical level and the information comes out in Google with no time. No time is, that means not zero time. It takes a time of within seconds, depends upon the internet speed. This is a simple example which I want to tell what are the levels of the database. I think you have got the clarity. The next topic is data independence. Okay, the data independence. The next topic is data independence. What is data independence? What we are doing in that? So how can we name it? This all should be have a glance on this. So let's go through it. The main purpose of data abstraction is achieving data independence in order to save time and cost required when the data is modified or altered or updated. Suppose we're updating some data. For example, earlier we used to have some window 7 or something like this. Now the Windows updation is window 11 example. For example, I'm telling you. So when the data is modified or altered, so what it is there, the data, what we are getting it should be independent. In no way, it has no concern with that internal things. Because it has to save time and the cost, because data retrieving, data abstraction and modifying, this is all has to be done to save time and cost. So the time is very important here. The information what we are gathering or what we are viewing and what we are doing, manipulating on them and what we are altered has to be done with data independency. So data independency can be clearly studied in the next lines. So we have mainly two levels of data independence uh, arising from the levels of abstraction. From levels of abstraction only, data independence has come into existence. What are the levels of data abstraction? That is the low level, physical level. Next is nothing but logical level. And the third level, the higher level is nothing but the view level. From there, we have two levels of data independency. Same like this, the physical level data independency, it refers to the characteristics of being able to modify the physical schema without any alterations to the conceptual or logical level. What is schema? Schema is a new word here. Schema is nothing but a structure. A human being has a structure. A tree has a structure. Next, a building has a structure. A book has a structure. So this physical structure, it refers to the characteristics of being able to modify the physical structure, that is the physical schema, without any alteration of the logical schema. So logical schema is nothing but the middle one. Okay, the middle one of the data levels of data abstraction, done for optimizing, for minimizing the purposes like conceptual structure of the database could not affect but any change in the storage size of the database system server, should not affect the server at all. So that is the main purpose of physical level data independence. Changing from sequential to random access is one such example. These alterations or modifications to the physical structure may include utilizing new storage devices, modifying data structure used for storage, altering indexes and using alternative file organization techniques, etc. See, I am running a system, a laptop. At the same time, what happening is I will click for the one, suppose I'll be clicking on the Google. At the same time, I can even access my Gmail. At the same time, I can even do some Google Pay or in the system. I can do some online payment also. Like this, multiple tasks can be done. So what happening is, by is this nothing? How this techniques going on? With the help of altering indexes and using alternative file organization techniques, like utilizing the new storage devices, modifying data structure used for storages. So the next slide comes to the logical level. It refers to the characteristics of being to modify the logical schema without affecting the external schema or application program. Application program is nothing but view. It refers to the characteristics of being able to, what is the logical level does is nothing but we can modify the logical structure. Logical schema, logical structure are the same without affecting the external schema, that is the viewpoint or the application program. The user view of the data would not be affected by any changes to the conceptual view of the data. The user view means the view level. So let's go little forward, backward. So this is nothing but the view level. This is the logical level and this is the physical level. Now this logical level is interface between the physical level and the view level. So whatever the queries has been typed here, it has to fetch from the physical level relate with the proper address, internal address of the logical area, and give the output to the view level. So this is the actual point going on here. For this is nothing but data independence. Let's coming to this here also. So whatever we are texting here, the top level has no need to know. He has no knowledge where the actual data is stored. We are not bothered also. How the system is logically being retrieved or retrieved and producing the data or accessing the data. The user has no need to know the access. This is called data independent. This is independent of this logical, and logical is independent of this physical. The view has no concern where the actual data has stored. In the initial stages, Google has one capacity of storage. But as the generations are growing and growing, the user no need to know where the Google stores the actual information. So that is called the data independence. So the next topic is nothing but different types of database users. So there are 7 types of database users in DBMS. So we have to know the users, the view level. What are the different types of database users? The first one can be the database administrator. So it is called DBA. DBA is a person or a team who defines the schema of the database and also controls the 3 levels of abstraction. What are the levels of abstraction? That is the physical level, logical level, and the view level. The DBA controls the 3 levels of abstraction. Next, the DBA will then create a new account ID and password, like user password and user ID, for like email address and password. For example, for the user, if he or she needed to access the database. Suppose I want to access my email account. What I do, I have to enter my email address and the email password. Then only my email will be open. Otherwise, no one can access it. That is called authentication password or something like we have to protect from hackers or something like this. So DBA is also responsible for providing security for the database. See, that's what I'm telling, security to database. And he allows only the authorized users to access and modify the database. So unless no one other knows our email ID is very universal, not an issue, but the password is nothing but only authorized users has their own passwords, right? So DBA, who maintains all this? The DBA maintains all this in other side of the distributed systems. Okay. Now the DBA also monitors the recovery and backup and provide technical support. It also gives a pop-up menu. Can the version be updated? So we get when we do some online works, can I update this version? So many types of pop-up menu comes. We have to click on that. Sometimes we may not click on that because the system might get slow or blocked or stacked or something like this. So DBA has a DBA account with DBMS, which called a system or a super user account. So what happens is the database administrator maintains an account in the database management system. So it is called a super user account. DBA also repairs the damages caused due to hardware and software failures also. This is the work of the DBA. This is the one of the type. Next is name or experience of parametric end users. Parametric end users are unsophisticated. We don't have any database knowledge. That is the customers, but they are frequently use the database application in the daily life to get the desired results. For example, frequently we log into the YouTube, Google, but we don't know what the actual internal process going on. We're only concerned with the queries and the answers. So that is called a parametric end user. For example, even railway ticket booking also, we are not uh, no need to know have the knowledge how the internal storage goes on. We just want our query and the answer. And the clerks in the bank is a naive user because they don't have any DBMS knowledge, but they still use the database and perform the given task. These are the few examples. Next. System analyst. System analyst is also user. You analyze the requirement of the parametric end user. He analyzes the requirement. They check whether all the requirements of end users are satisfied. System analyst, what he does, he checks whether the requirement of the end users is being satisfied or not. The next user is nothing but sophisticated user. It can be engineers, scientists, or business analysts who are familiar with the database. They can develop their own database application according to the requirement. They don't write a program code, but they interact with the database by writing SQL queries directly through the query processor. So the query processor is nothing like a template where the templates will be producing where you have to fill up fill in the blanks. You have to fill up the columns and press the enter. For example, what is your first name? A block comes next. In that block, we have to fill up the first name. What is your middle name? What is your last name? After every filling up, you press enter. Automatically, the cursor goes to the next uh, next box. So this all called sophisticated users. They can be engineers, scientists, or business, or analysts, or any other learned man, but they don't have any knowledge of the database, but they are very much familiar with the queries and filling up their online applications like this. For example, using a ticket, filling up the ticket, online applications, online exams like this. Database designers. There are many types of database designers according to the market. So many designers has been evolutioned, but we are some only few people use that because they use the tables, indexes, views, and constants and triggers and the stored procedures also. I used to design the structure of the schema of the database, which includes tables, indexes, views, constraints, and triggers. Triggering means it automatically, when the particular any changes happen, automatically it gets um, running the program without any intimation. It does it by default. So this is called triggering. And there is a basic, some command is there for this, which is coming in the third unit. And stored procedures. This is for stored procedures can be a macros also to some extent. He or she controls the data must be stored and how the data items can be related, how it can be controlled, how it can be stored, and how it can be related. So this is all to be monitored, updated, etc. This is all done by database designers. The next part of the designer is the next part of the user is application programmer. Is a backend programmers who writes the coding part for the application programs. They are computer professionals. So these are called coders or developers. These programs can be written in programming languages, a Visual Basic, Developer C or C hash, Fortran, Cobalt, etc., etc. Casual users or temporary users are users who occasionally use or access the database, but each time when they access, The database that requires the new information. So all the time it is also having a fresh account. Account can be the same, but the fresh, all the time repeatedly ask. For example, when I have a Zoom meeting, every day I'll be updating my date and everything. Okay. Like that one. For example, middle or high level languages, high level manager. Okay. Some half an hour is over. So abstraction, uh, levels of abstraction and DBMS and data minutes has taken 15 minutes. Now coming to the structure of the database management system. So structure of database management system is quite a big topic. It may take up to 20 minutes also. So let's enlarge with the diagram. So structure of database management system. Here the end users are the administrator or users or application programmers. So it has to interlink with the logical data, and this let's lastly come to the physical data, and this is the view data. Okay, in this DBA, we are having database schema and DDL compiler. Compiler means which can change our English type of language to the system or a compiling type of language or macro instructions or micro instructions, which is understood logically by the logical level. Next, we are queries and queue process, application programs or DML manipulating language programs, which is done by the compiler. The query processor interact with each other. The next, the middle level is nothing but the logical level, where data dictionary manager, authorize control, query optimization, optimizer, command processor, translating manager, scheduler, recovery manager, buffer manager. This all has been called as data manager. So this data manager, what happens is it has to connect with the data dictionary, to and fro connection. The last one is nothing but the physical. The data files and data dictionary are stored in the disk. So disk means they show that cylinder type where hardware is stored. So coming to the diagram. What is this query processor going on in the user? So that one you are seeing first. It interprets the request queries received from one end user via the application program into the instruction. It also executes the user request, which is relayed from DML compiler. The query processes contains the following components. So what I want to explain here is, it interprets with the request or the queries received from the high level, that is the view level, via a logical program into instructions. It then executes that with the help of user request, with the high level user request, which can be received by the data manipulation language compiler. Query processor content. Okay, what is this? Which part it is telling that? It's telling this part. Okay, so this is telling this part, which will interface with the query processor to form from the application programs to for the data manipulation language with the compiler. So that is a part here. Mm. The commands are DML commands and DDL interpreter. So these are the DDL commands and DML compiler. Okay, these two commands are the definition language and manipulation language. What is DML compiler? It processes the DML statement into low-level instruction, that is machine language, so that they can execute. So manipulating language, what it does, it processes the statements of DML level into the low-level instruction in the machine language, so that they can execute. Interpreter is nothing but DDL statements into set of tables containing metadata. Metadata means data about data or data within data. The next coming the embedded Dml Pre-Compiler. It processes the DML statements embedded in the application program into procedural calls. So it changes to application programs into calls, procedural calls. So this is here happening here. Optimizer and dictionary. This is all going on here. Query optimizers is instruction generally by data manipulation compiler. This is called query optimizer. Next, data storage. The next part is nothing but the data storage. So this part we are seeing here, the data dictionary manager or the data storage. Here the data is to storage, the help of by getting monitored by the database manager. Okay. The storage manager is a program that stores the interface between the data stored in the database and the queries received. It is also called database control system. It maintains the consistency and integrity of database by applying some constraints, restrictions, and executes the DCL statements. It is responsible for updating, storing, deleting, and retrieving data in the database. It has following components: authorization manager and integrity manager. So this is integrity manager and authorization manager. Okay. Transaction manager, where it tells and controls the transaction and the schedules. It controls the concurrent access by performing the operation in the scheduled way that it receives the transaction. Thus, it ensures that the database remains in the consistent state before and after the execution of the transaction. File manager, it checks the file space and data structure used to represent information of the database. Transaction, what it does, it controls the concurrent access. Concurrent means at the same time. Access like give and take. Okay. Giving means like crediting and debiting like this. And performing the operations on that, on the command and receive the transaction. To ensure the database remains in the consistent state before and after the execution of the transaction. The buffer is nothing but is responsible for the cache memory and transferring data between secondary storage and the main memory. It's a temporary device. So disk storage, it consists of the following data files. It stores the data dictionary. It tells the information of the structural database. It is a repository of information and governs the metadata. Data within the data is called metadata. Introduction to database design. This is the second topic, second half of this. Okay. Let's have a break.